Okay, good morning children. Today we are going to study the Newton's universal law of gravitations. Universal law, there is a word universal law. Newton's universal law of gravitation. Universal law of gravitation. The force between any two particles, that is a point object or not. The force of attraction exists between them, no matter whatever the size of the particle is there. And this is called gravitations that Newton maintained a law concerning this force of attractions between two particles is called as a universal law of gravitation. And we have a common experience. If any object is allowed to let fall free under the action of the gravity, it goes downwards. That means the force of attraction exists between these two particles. If the earth rotates around the sun, that means there is definitely the force of attraction existing between them. The sun is also has also mass, the earth has also mass. Alright? The sun is exerting force on the earth is also exerting the force on the sun. So we will discuss later on of all these activities, how does it happens. But before going to have a knowledge that one, we should know what is the universal law of gravitation. Alright, so I am going to write here every particle in the universe exerts force of attraction force of attraction on every other particles. Exerts the force of attraction on every other particle. Alright? Or you can say there is a force of attraction between two particles. And what is the nature of that force? The force of attraction between these particles is number one, directly proportional to the product of masses, and second, inversely proportional to the square of distance between them. So this is the law. In the senior section, when you go to the class 11, there is an inverse square law and we have to prove there, but this is not a part of your syllabus. That's why I am not going to teach, but if I get a time, I will teach you definitely. Inverse square law. There is a proof that how does the inverse square law happens and how does it get proof. So here, every particle in the inverse, no matter whatever the size of the particle is there, if I take a duster or two marker, here it is, the force of attraction is also exerting between them also. Alright. Then question arises that if the force of attraction is working there, then why do not they get stick together? Or why do not they get collided? All these things are there. We will discuss one by one. So first, every particle in the universe exerts a force of attraction on every other particle. The force of attraction between these particles. What is the nature of the force of attraction works? But how does it work? That is directly proportional to their product of the masses. What is the meaning of the directly proportional to the product of their masses? It means if the mass increases, the force of attraction also increases. Alright. That means if one has the greater mass, it means it has the more force of attractions, as it happens in the case of the sun and the earth. Alright. And second is that inversely proportional to the square of the distance between them. Inversely proportional. What is the meaning of inversely proportional? If we increase the distance between the particles, alright, that means the force of attraction decreases. Just inversely. Inversely means opposite relations. If you increase the distance between the particles, that means the force of attraction gets weakened. So let us prove here. See here. There is a two mass, point masses, and here it is other mass. Suppose the mass of M1 and here mass M2. There are two masses, M1 and M2, have been separated by a distance R. Pay attention here, we do not take the distance between here. This is wrong method. This is wrong. Generally, the common people will take this thinking that the distance between the particles from here to here to here is no, this is wrong, because the center of mass, alright, the mass of whole body is concentrated in the center of gravity. And this is the spherical body. We have taken the spherical body. That's why the center of mass lies at the center of gravity, and here the center of gravity is the center of a spherical body. That's why you take the distance from here to here, not here to here. This is wrong method. So now, see here. So first, from the first part, from the first part of Newton's universal law of gravitation. What is force is directly proportional to the product of the masses. This is the product of the masses. We take the product of the masses. That means if we increase the mass, that means force also increases. And from the second part, of the above law, force is inversely proportional 1 by square of the distance. This is known as inverse square law. There is a proof in the class 11 how this law comes into existence. So in class 9 there is no proof. Make your time, I will teach you differently. So these are the formula. These are the thinking that we have taken it from the statement of universal law of gravitation. So these are the two things. Force is directly proportional to the product of masses and inversely proportional to the square of mass. Now we combine first and second. Combine. Now combining equation first and second, we get for F is proportional to M1 M2 by R squares. Alright, this is the thing. This is the proportional, and we know that we have to remove this proportional. So we find here a constant quantity, and here the constant quantity is capital G, M1 M2 by R square. This G is called universal constant of gravitation. We have to keep in the physics, according to my wish or your wish, any quantity cannot be considered as the constant, because the constant has a particular value. So we have to put here the G. We do not put here K. No, this is not applicable here. We have to put here G, capital G, universal constant of gravitation. So this is the law. F is equal to G M1 M2 by R squares. So now we are interested to know that what is G? Alright, we know, yes, it is true that it is a constant, but just I told you that every constant has a certain value and a certain meaning. So what is really G? What has its role? So let us see here, M is equal to G M1 M2 by R squares here. Suppose if you want to know the definition of capital G, then what can you give the definition? Suppose this mass has a unit mass. Alright, this has a unit mass. Hello? আরে দাঁড়ান, আমি এখন স্কুলে আছি, অনলাইন ক্লাস করছি, এখন আমি পারবো না, ক্লাস স্কুলে আছি, ঠিক আছে? তাহলে ওই দুটো তিনটের আগে আমি ফ্রি হচ্ছি না, তো দুটো তিনটে পর। So here it is M1, it is 1 kg, and here it is 1 kg, and here it is distance, suppose here it is a 1 meter. So now we put the value here. If we take a unit mass here and they are separated by a distance 1 meter, then what will be here? F is equal to G M1 M2 by R squares. So G 1 into 1 by 1. So what is G? So G is what? Force. But we cannot write here that the G is a force. No. We can say that gravitational constant is a force. What is the condition? When the unit masses are separated by a distance of 1 meter. This is the way we have to define that universal gravitational constant is a force between two unit masses when they are separated by a distance of unit meter. So we can write here G is defined G is defined as a force of attraction between unit masses separated by a distance of unit meter or 1 meter. So G is defined as a force of attraction. We cannot say simply that G is a force. No. Then the G will have the unit of Newton as a force of attraction between unit masses separated by a distance of unit meter. So this is the G. By an experiment, a Cavendish, it was not Newton who discovered the value of capital G. No, it was the Cavendish who find out the value. And this Cavendish. This is the experiment. He took the unit masses, and there is an experiment. But all these things are to be discussed in the class 11. Cavendish. So the value of G, he observed. He found out the result. Cavendish, not the Newton. G is equal to. Acha, what is the unit of G? Just a minute. SI unit of G. F is equal to G m1 m2 by r squares. So G is equal to Fr square by m1 m2. It is force Newton, r meter square, and kg into kg square. Or in other words, you can say Newton meter square kg inverse 2. So it is clear now. It is not a Newton. It is Newton meter square kg inverse 2 or Newton meter square by kg square. Simple. The unit of force Newton. Here it is a meter square and kg into kg square. So Newton meter square is kg inverse 2. So now this is the SI unit of G. So the value of G, capital G, it is 6.67 into 10 to the power 11 Newton meter square by kg square. The speciality of these values is that its value will not change. No matter if you change the place, if you change the time, if you change the weather, nothing. So generally a question is asked that why G is known as a universal constant of gravitation. Why this is called universal law? Things cost the why Newton's law is called as a universal law? Because this law is applicable at all places, at all time, at all weather. So no matter whatever the changes here, it does not matter. So generally a question is asked that why this law, or why Newton's law of gravitation is known as universal law of gravitation. Why capital G is called universal constant. In any way the question is asked. Why gravitation is called universal law of gravitation. So first, it is applicable at all places. This law holds. Yeah, if it is applicable, can we write here? It is applicable at all places, at any time. At any season. So you can add at. No more point, but simply is you can say that this law is independent. This law is totally independent. This law is independent. Totally independent. In other cases we have seen, if you see the other derivation of the formula F is equal to MA or anything, or even you say you will go to the class 10, there is Ohm's law, there is a R resistance, this is also a constant. But this constant changes if we change the other physical quantities, whether it is a time, temperature. So this law has nothing to do with the time, with it is a day, at all time, at any time I am waiting now. It's a day and night, whatever it is. At all seasons, does not matter. Whether its humidity increases or decreases, does not matter. At all places, no matter. So it is totally independent. That's why it is called universal law. If you see the other law, there is no word universal. That means the other law, the other constant quantity is not a totally independent. It depends upon some other physical quantities. So this is the law which is a totally independent. That's why it is called as a universal law of gravitation. So this is the thing we will discuss later on.